For problem number 13, it says in a velocity selector, the uniform magnetic field is 1.5 Tesla. Of 1.5 Tesla is produced by a large magnet. Two parallel plates with a separation of 1.5 centimeters produce perpendicular electric field. Produces, I think there's a typo there. What voltage should be applied across the plate so that, for part A singly, I think that's a typo too. I think that's supposed to say a single charge. What's single charge? Ion traveling through at 8.0 times 10 to the 4th meters per second will pass through undeflected. And part B, a doubly charged, maybe it is singly. I'll have to look in the textbook. Ion traveling through at the same speed will pass through undeflected. All right, so I know what to do, even though I'm not sure if there's a typo or not. For part A, remember the relationship is the velocity is equal to the voltage over the quantity or the magnitude of the magnetic field over the distance. And so if I solve that for big V, let me put it in a different color because right now they look like they're the same. So this is voltage, the green V is voltage, and the little v is velocity. So to solve for the big one, I just get voltage is equal to little v times B times D. All right, so the voltage is equal to the velocity times the magnitude of the magnetic field times the distance. So let's write some of this stuff down. Before I plug it in, I know that the velocity, little v, is 8.0 times 10 to the 4 meters per second. I know that the magnetic field is 1.5 Tesla, so capital B is 1.5 Tesla. And I'm double checking all these units. Tesla very rarely does a physics textbook make you convert. Almost always the fields will be in Tesla. Sometimes you'll have like mega or micro and you got to put it in scientific notation, but in this case it's just Tesla. And then, we need the distance. And so the distance, if I remember correctly, was given in centimeters. So we do need to convert that to meters. So 1.5 centimeters converted into meters is that 0.015? Yeah, so 0.015 meters. All right, cool. So we have all of our units right. So let's just plug that into our equation. So the voltage then is equal to 1.5 Tesla. Darn it. We gotta do the velocity first. 8.0 times 10 to the 4th meters per second. Okay, that's good. Times the magnetic field, 1.5 Tesla. Times the distance, which is 0.015 meters. And if I plug that in the calculator, let me double check, make sure I have everything correct. Times 10 to the 4th meters per second. 1.5 Tesla, 0.015 meters. Yep. So that should be, our voltage then should be 1.8 times 10 to the 3 volts. Okay? So that's the answer for part A. And I'm going to recap that because even as I read it, I had to think about it. So it says what voltage should be applied across the plates so that a singly charged ion traveling at 8.0 times 10 to the 4th meters will pass through undeflected. And so the answer to that is 1.8 times 10 to the 3 volts. Now for part B, it says a doubly charged. So now if we double the charge on this particle, somehow it'll have an impact. So when we double the charge, well, it may or may not have an impact. So notice that this particular calculation, it doesn't care what the charge is, okay? So the part B is kind of a trick question. For part B, if we double the charge, guess what? It's still 1.8 times 10 to the 3. And the reason it's the same voltage is because it's independent of charge on the particle. So independent of charge on the particle. So that's kind of a trick question. I hope you guys didn't go through and try to find a formula with Q and plug it in. You don't need to.